So when thinking about how do you define metadata for such a diverse array of possible objects? So this is the Metaplex's standard. Basically, this is how Metaplex did it. It's like there's fungible tokens, there's non-fungible tokens, and here's our structs. And if you don't like the structs, you're kind of out of luck. So there's a lot of creative teams out there who are coming up with their own ideas for how to do metadata, and they're kind of blocked. Like this is kind of a problem you have to look out for when you're designing a system from the ground up. Is that you can move fast at first, but if you don't design with extensibility in mind, you'll end up with a system with so much technical debt that it's just hard to add on top of. And that's the situation like Solana is basically in right now. So you can see they just like define some attributes and then fix types, and that's whether you like it or not. You want to add something else to it, you want to change those, it's not happening. And then the second, that was the first consideration. The second consideration was we want to have metadata on chain wherever possible. So this right here is a DGOD. It sold $220,000 back in September. And you ask yourself, when you buy a Solana NFT, what are you really buying? What are you getting? In fact, all you're getting is a record that points to a URL. So the metadata is not actually on chain at all. So all you get is, and in this case, it's pointing to dgods.com/269JSON, because this is dgod 269. So when you're paying $220,000 for this NFT, all you're getting is a tradable pointer to a JSON file stored on somebody's AWS server, which is not great. So if this server goes down, if it's unavailable, if DGOD decides for whatever reason to, they just want to unilaterally change that. They don't want it to be that cool anymore. They just want to change whatever they want. They can do that. So wouldn't it be nice if there was some sort of way of having a highly available data source, if there was a way of sharing like ownership and guaranteeing that people aren't going to just change it from underneath you? Well, it's called a blockchain. It turns out we have that. So a lot of the things I'm going to talk about make other ecosystems look kind of dumb. But it's not that they're dumb, it's just that like Sui enables us to do things other ecosystems couldn't do. So when Metaplex made all the metadata off-chain, they didn't do that because they were like, this is a great idea. They did it because of the limitations of Solana. So Solana has a 1,200 byte count limit. So that means whenever you create an object in one transaction, you can only get 1,200 bytes. Storage is very expensive on Solana. We're talking 1 kilobyte or less is 5 cents. Back when Solana price was 10x, but it is now it's 50 cents. People were paying $5,000 to load a candy machine with 10,000 NFTs. And that's with the metadata off-chain. Imagine with on-chain, how much that would cost them. So they were building around these technical limitations that they had to deal with. But Sui storage is fortunately going to be, I'm hoping, so far projections, at least the definite gas prices are right, it's going to be several orders of magnitude cheaper, which makes metadata on-chain viable. So now we arrive at our two guiding principles around capsules, right? We want on-chain metadata because it's highly available, we can control who can edit it and such. And then we want unopinionated schemas. So I don't want to force people to be like, you have to have a name, and it's an image, and you have to have an image, and you have to have these attributes and stuff. Like, I'll leave that to you guys to decide. I'm just going to give you guys the tools for creating data and managing your ownership of your stuff. So before I explain how Capsules works, I have to lay a little bit of groundwork. You have to understand a few patterns. So Ty kind of spoiled this on day one, but this is the extend pattern. So one of the superpowers of Sui is dynamic fields. So dynamic fields let you grab an arbitrary object and then attach your own fields to it, without that other object knowing that you're doing this. So in this case, we have this code right here. We have an outlaw. I'm just asserting that the owner is presenting this outlaw, and then I'm returning a mutable reference to UID. So UID is the key that unlocks the dynamic fields. So you've taken a piece out of this outlaw object, and now I can add my own custom field to it, right? So I just go dynamic field add, key, and then whatever I want, in this case, hello world. So you might think that this is insecure in the sense that, like, well, if anybody can, like, add fields, couldn't they change your fields? Like, so you notice I'm using a key. So because only my module can construct that key, only my module can read and write to that specific dynamic field. So the pattern we're going to be doing here is you have an object that somebody creates. Then they pass a mutable reference to the UID to other programs, and those other programs attach their own data to it. And it makes this very dynamic, composable sort of behavior between objects. You're composing objects directly. And you can't do this in Aptos, you can't do this in really any other ecosystem. And I think this is kind of a game changer. Other game changer is view pattern. So the idea for view pattern is that they call them DevStack transactions officially, but I call them view functions. The idea is that in this case you can pass in an outlaw, you pass in a schema object, and then we are returning bytes, which allow you to understand what that is. These are just some very simple examples. In the second example, I just have my field, which is a struct, and I'm serializing it and then returning it. So you can build your own custom view functions. These are like trivial examples, but you can imagine like if you had like a coin object and you wanted to return different images depending on like the balance inside the coin. You could create your own custom logic to do that. So you get to decide how your objects will be presented to front-end clients. So first we're going to talk about the ownership in Suite. So in Suite, they have two notions of objects, states the object can be. Right? It can be a shared object or it can be an owned object. Owned object, if you can get a reference to it, you have authority to use it. Shared objects, it's not that simple. So anybody can get a reference to a shared object, right? And then, but the question is, how do you gate access to that? How do you gate control of that? And like, Suite is kind of like has no opinions. They're like, you figure it out. Okay, so that leads to like a lot of custom behavior that you have to build in if you have like a shared object you want to control. So this is just a toy example I wrote up. So the basic patterns for owning an object is you have objects that are owned by addresses, which is a key pair. So like, I have a secret key pair that I have, right? And I'm able to produce a transaction. That's how I can assert that I own it. It can be owned by other object IDs, or it can be owned by types. So if you've ever seen the coin capability treasury cap, that's like an example of a type. In the case of object IDs, it's like representing that I have this certain object ID. It's like, look, I have it. See, this is my proof of authority that I should be able to modify this in some way. So that makes your interface kind of complicated if you're trying to support all of these. So in this like toy example, I have a bank account. And one bank account can be owned by key pairs, another one can be owned by IDs, another one can be owned by types. Kind of a little complicated, and then if you want to transfer between these two different bank balances, you do 3 times 3 equals 9 different like transfer possible functions. So like so let's go for that first one, transfer from object to address. In this case, I'm presenting an owner object. I'm presenting the bank account. These bank accounts are shared balances. They're shared objects, by the way. To clarify. I'm just checking to make sure that it's the owner. Well, I'm getting the object ID of the object you presented, and I'm making sure it's bank equals owner. And then I'm allowing you to proceed and like withdraw the balance, change the balance, etc. So I realized we could simplify this with a new program that I call transaction authority. So you've been using transaction authority the whole time under the hood, but you just didn't call it that. You call it transaction context. So if you go inside transaction context, what it has is it has the address of the sender. And so you know who the sender is, and you can be like, okay, TX sender equals bank.owner. Okay, great, we'll keep it going. But what if we could extend it? What if we could extend it and make it more than one address? And one of those addresses, instead of just being like key pairs, what if they could be object IDs? What if they could be types? Like, we could do a lot of things. So what you do here for this pattern is you call in the TX authority and you present something. Like in the case you begin with ID, you're presenting a capability object. So you have this object, and it takes the address, adds it to the vectors of authorities. So, and then you can pass this authority object to a future function, and that future function will be like, oh, well, I see that the object ID that you added to this is like a rubber stamp, and boom, it's on there. Good, we'll pass. We can do the same thing with type capabilities, but types are a little more complicated, but essentially what you do is you take the type as a string, you hash it, turn it into like 20 bytes, and then you use that instead. So this really simplifies our bank example. So instead of having like 3 different banks, we just have one bank, and we don't even define the owner in the module ourselves. So in this case, when we want to create a bank, what we're doing essentially is, I can walk you through these lines, is you're setting up the ownership. Okay, so you have proof equals ownership set up. Maybe I'll come over here, this will help a little bit. Okay, we're setting this up. What this is doing right here is we're adding this witness right here. So this is a witness that only my bank module can produce. So it's like, how does modules sign for themselves? Modules can't have secrets, right? So only my module, the bank module, can produce this witness. So it produces this witness over here. It adds it to this TX authority, and then it passes that along with the proof to to this bank object to initialize its ID. And that's just a check that I have in for everything, because I don't want other modules initializing ownership for something they don't own. Like, only the module defining the bank object should be able to define ownership for the bank object. You know, so we don't want other people like hacking stuff. So it's initializing ownership, and then it's initializing that transfer authority. You probably won't get into the transfer authority, but it's a set of rules by which ownership can be transferred. And this could be like a different module entirely. But yeah, basically just setting owner, and then we're sharing the object. So then in the future, when you want to, let's say, transfer balance, you would just call back into the ownership program, and like, is this authorized by the owner? Okay, we have the authorities that we've received so far, right? Which is just that, it's just a vector of addresses that just seen as a vector of addresses that just stand today. Yeah, Paul signs off on this, the bank module signs off on this, that one object we needed a reference to signs off on this, like, and we're just carrying this forward, right? So we can just assert that this is authorized by the authorities we would expect, and then we can allow the rest to proceed for the transfer. So this allows you to simplify your API, this allows you to simplify the ownership. And once dynamic transactions or programmable transactions are live, this will be a lot easier in the sense that you can simply produce these auth objects and keep passing them forward throughout your whole execution. So I'm going to walk you through the creation of basically like, it's an outlaw, basically the equivalent of like an NFT. So we have a project called Outlaw Sky, so that's why I can talk about outlaws. But basically, we just have a struct, and like all it is an ID. I'm not defining anything, right? And then we're going to add ownership fields and metadata fields, add those there as comments, so that like, people know what's going to happen. Now I create my own outlaw right here. We go through some ownership stuff. I'm initializing it. I'm like, I own this. Basically, I'm the module that owns this. We added our witness up here. Then we're attaching some metadata. We're going to get to metadata in a little bit. But you can see the metadata is coming in. It's just a vector of bytes, a schema we're going to track the schemas in a little bit, but that defines how the data is going to be formatted. So we're just initializing ownership as the module. We're attaching some metadata. Then we're adding the actual end owner, which is like the consumer presumably buying the entity, assigning it to a transfer market, and then we're sharing it. And that's about all you have to do. So this module as Outlaw didn't have to define its own metadata standard. It didn't have to put all its own fields. The metadata fields didn't have to be arguments in here. The schema's flexible. Yeah. So I want to talk about like metadata, where that metadata came from. So we have what I call an ORM, like an object relational mapping, and like it's nothing special, but we're over in TypeScript right here. So in TypeScript, let's do like a client application. I'm defining like a schema from Outlook. So I'm like, okay, I want name, description, image, power level, attributes, something like that. That's just a schema. And then I'm instantiating the schema. You know, attributes, we got background white, we got like an image here, we got a power level, which is U64, description, we can leave that optional, right? So schema, instantiate schema, and JavaScript doesn't actually have runtime types. So like if you really want to be anal and you want to assert it, you can assert being like, yeah, make sure those two things match. And then we're just, this is actually like all using out-of-the-box stuff from Houston Labs. So like they have their own library called BCS. BCS stands for Binary Canonical Serialization. So it was this serialization format that they developed at Facebook along with Move. So all we're doing is like they have a little library for that. So we're registering a struct type, we're calling it outlaw, and it's our outlaw schema right up there. Wow. And then we're serializing this object using the schema, and so we're going to get a bunch of bytes. We're going to get a bunch of bytes, really simple. And then after that, we're just going to call into our create function, pass the bytes. We're going to pass a reference to a schema object ID. So this is there's an object on chain that'll say something like similar to what we had. It'll list out that like name, description, image, stuff like that. So that's so on-chain, we know how to deserialize these bytes that we're doing right here. So yeah, and that'll create the function, that'll create the object we had before. Then if you want to go back again, do the reverse. We can do view functions, do the same thing. So in this case, we're just going to call back into our function view all. We're specifying the object ID, the schema ID that we're expecting. We do a dev inspect transaction. Dev inspect transactions do not cost anything. They're super helpful. And we get the result, we parse the result, and we deserialize the result, and then we have our outlaw. So like the original object that we created, this right here, we posted that on chain, and then we'll get it back. And like this isn't using any like weird proprietary libraries or anything like that. This is all just like out of the box kind of stuff. That's like what I call an ORM. If you guys are familiar with that term. So more generally, I didn't get icons for these. Wow. More generally, I've defined so far like 5 types of metadata. So far we've talked about like object metadata. So that's just specific just to an object. But you can also have other types, so abstract type and concrete type. So Tamir has something along these lines a little bit, and in the coin metadata, in the coin program, if you look in there, there's kind of its own notion of like type, a concrete type metadata. So let's get into that actually. So this is like the coin module. Sorry, it's so big, you don't have to look through it. But this is how it's currently implemented in the suite. It's like we have a coin metadata object, and it defines all its own fields on chain. Decimal name, symbol, description, icon, URL, and then it shoves all of those into like the function argument to create it, and then they create like 9 other functions to get those and modify all those, right? So let's try simplifying that like a little bit. So the way we can simplify that a little bit is we're passing an abstract type. So if we have something that's not concrete, like coin T can't exist. Coin T isn't like a concrete type. Coin T is it's a template to create types. So that's what I mean by an abstract type. So I would define some abstract type, and I would presumably like pick a schema similar to the one that they already have in the token metadata program. Then I would pass in the schema, I pass in some data. So we create the object. Yeah, what are we doing? Given type. Yeah, okay. So I'm returning this type object to you. So you can think of a type object as a singleton sort of store. So like I've defined this new coin, that's called Paul coin. I'm going to get back a single like object called type Paul coin. And I'm going to be able to, like we were just doing with the outlaws, I'm going to be able to modify the types and all the metadata stored on it. And then a client application will be like, what is this? What is this Paul coin thing? Instead of me storing for every object ID all that data, which would be pointless, they're just going to call into that one type object and be like, oh, okay, I know what this is. All right, cool. And yeah, that helps me control how my type generally is presented. Let's see. Now we're talking about creators. So here's like a pretty innovative idea. So anybody can create a creator object. So you just create, and it just essentially lists the packages, and then you can attach metadata to it, whatever scheme you want to have decided. So anybody can create one of these. So you can imagine like Yuga Labs or DGODs, they have one of these creator objects. So it's a root level shared object sitting there. But now we can provide kind of like a trust layer to this. So like a big problem that Slum's run into, and that Sweet will definitely run into, is fake NFTs. So like, how do you know somebody's gonna like steal some artwork, mint it on chain, create 1,000 of them, airdrop them, and how as a marketplace, how do you distinguish from these real ones versus these fake ones? So this is kind of where a creator comes in. So when I publish a package, suppose I publish Outlaw, I get an Outlaw Sky package, publish receipt package. And then I use that and then I add that to my creator. So now I've proven that let's suppose Paul Capsules. And then I add that, I use the publish receipt to prove that I was the publisher. Paul, the creator, was the publisher of this package. And now anything that comes from that package, any objects produced by the package can be attributable to me, to my creator object, right? Because we linked the two. And so what if we used dynamic fields in the extend pattern to allow people to add their own stamps to my creator object? So you can imagine Muslim Labs themselves, you can imagine Origin by Shinami, Keepsake, anybody. They would essentially call in as and they would add their stamp or approval to a creator object. Be like, this creator is legitimate, and then something like Ethos Wallet, they could see that, and they'd be able to query that, and they'd be like, okay, this NFT was produced by this one package. This package is owned by Google Labs, and Google Labs is stamped by Mr. Labs as legitimate. So now I know to display this, that I feel safe to display this, rather than some other sketchy shop that doesn't have that. And these endorsements can be added and removed. And so it's kind of like a trust and safety layer system. The idea, I took the idea from SSL certificates. So essentially, when you get an SSL certificate, it's signed by an authority, and it's like, oh, I trust Google. This is Google's signature. Yeah. So I can proceed. That was pretty much what I wanted to talk about for like the main focus of my timer. I'm not sure how far along I am. But thanks everybody for showing and listening. Do you have any questions and stuff? Yeah, I'd love to hear questions from anybody.
Wow. Well, before we get any further, I think it would be great if everyone could get a round of applause.